max min of functions with several variables. Today is the 25th, I think. So 6.3, max relative, max or min for functions of several variables. We're going to learn about the D test. So section 6.3, just for your information, because we're going to pick problems in a minute. Section 6.3 starts on page 542, and we're looking at 547. So we're looking at what it's called the D test. And this is going to be the last topic of this course. And we're going to slowly go over the steps of the D test. So let's start with the problem and then a word problem, and see how we determine max min for functions of several variables. Okay, so on page 547, let's say we start with problem 10. 547. We're given a function of two variables, f of x comma y is 4y plus 6x minus x squared minus y squared. I check because I always, not always, but most of the time, I copy. Okay, perfect. First step towards the D test, finding the relative. This is what we're asked to find. We're asked to find the relative max min of this function. Before we do that, I just want to show that functions of two variables are surfaces. So this is an example with a function of a and b, or a function of x, and this function has a maximum. This function has a minimum. This function has more than one relative max. So relative, in this case, an absolute and relative max. We will not deal with absolute max at all. We're going to just find that these two are relative max. But look at this one. Here's what happens here in this situation. This is not a relative max. This is not a relative min. This is so-called the saddle point. Just imagine the saddle on a horse. This point here is not a max or a min. It's a saddle point. Okay. So in first step, we have the function. First step, we have to determine fx, and we established last time that fx is the partial derivative of f with respect to x. This is constant when I differentiate this. So for this function, I keep y constant. If you need us to write it, let's write it. Y is constant. So 4y prime will be 0. 6x prime will be 6. Negative x squared prime will be negative 2x. And y squared will be 0. We also, in the same step, we determine fy when x is constant. Okay. So now 4y prime is 4. 6x prime is 0. X squared prime is 0. And negative y squared is prime is negative 2y. This is our first test, our first step in determining relative min for functions of several variables. Now step 2. We want to create a system of equations from fx equals 0 and fy equals 0. We have them. We just determined them in the previous step. So now we are going to write 6 minus 2x equals 0 and 4 minus 2y equals 0. Obviously, the first equation gives us x equals 3. Very good. And y gives us the point we are looking at is 3, 2. In step 3, we want to determine fxx, fyy, and fxy. fxx, fyy, and fxy. Going back, fxx, it means that we differentiate this function with respect to x one more time, and the answer is -2. fyy, it means that we differentiate this function one more time with respect to y, and the answer is also -2 in this case. Also, fxy is this function differentiated with respect to y, but there is no y in it, so it will be 0. Final step of the test. Calculate d. Okay, what is d? d is fxx at the point 3, 2 that we just determined, multiplied by fyy at the point we just determined, minus fxy of the point that we just determined, but this quantity will be squared.
Oh, squared because it's fxy and then fyx, but they're the same.
Exactly. Okay. We will determine the number right in a minute. So here are the options. If d equals 0, inconclusive. In other words, the test is not applicable. D test not applicable. If d is negative, it's the situation that I just showed you, saddle point. Meaning not relative max and not relative min. The only situation in which we are interested in is when d is positive. And there are two options. If fxx is negative, the function has a maximum. If fxx is positive, the function has a minimum. Really? Ready? So let's write the two options. fxx negative, rel min. I meant to say max, I'm sorry. fxx positive, rel min. Let's summarize before we finish. First, we found fx and fy. Then we created the system to find the point. Then we determined fxx and fyy and fxy. Then we calculated d as fxx at that point times fyy at that point minus the partial combined at 3, 2 at the same point squared. If I get the answer to be for d 0, test is inconclusive, not applicable. If I get a d is less than 0, there is no max min. No max min, relative max, no relative. But if d is positive, there are two options. If fxx is negative, then 3, 2 will be a relative max. If fxx, that we'll calculate in a minute, is positive, then 3, 2 is a relative min. Ready? So now let's finish it up by calculating this. So fxx of 3 comma 2 is negative 2. I can't even plug anything in here. So I'm going to write that D equals negative 2 times F y. Again, I cannot plug in 3 comma 2 because it's negative. Minus. This, I cannot even, it's such a simple example that I cannot even plug in 3 comma 2. So it's 0 squared. So this is this situation where f(x)(x) is negative. But if D is not a positive number, then there is no relative max. But it happens that this is 4. D is a positive number, as well as f(x)(x) is a negative number. So then I will conclude that 3 comma 2 is a relative max. And that's the entire procedure. It's very different than finding max min for functions of a single variable, as you see. So now we can choose anything you want. Now we can be asked to find the relative max. And I think, yes, and they say find the relative max and minimum values. So not just where the point is. So I go back to the function. And what do I do to find the relative max? What do I do with function of single variables? I'm telling you that that maximum is at x equals 1. Find the maximum. What would you do? That's it. So f of 3 comma 2 equals 4 multiplied by 2 plus 6 multiplied by 3 minus 9 and minus 4. So this will be 8 plus 18 minus 13, and it's 13. So the relative maximum for this function of two variables is obtained at 3 comma 2. The actual maximum value is 13. And this is the end of the course. Okay, so now please choose anything you like. We can look at more examples with max min and then go back to 6.1 and 6.2 and choose more problems.
Isn't there another one of these problems?
Of course, yes.
Can I see page 2 really quick, please?
You mean this one? Yeah.
Up higher. I didn't get part one.
Okay, so let's look at maximizing profit. Oh, that one. Oh, I'm sorry.
Okay.
Oh, you said page 2, that's why I was looking at page 2. Maximizing profit, number 16. Would you like to work on another problem that is not a word problem first?
Yes.
Yes? Very good.
Can we do 14?
Yes, let's do 14.
Same page.
Same page, 547. So here it is, fxy, f of xy equals e raised to x squared minus 2x plus y squared minus 4y plus 2. I'm checking that I copied it correctly.
Yes.
Perfect. Okay, so the whole thing is the same. Thank you. Is this okay?
Well, let's see.
Perfect. So the same question. Find max min for this function. Ready? What is the first step? Fx first. Good. So I'm differentiating this function with respect to x, keeping y as a number. Remember, this is e to u. When I differentiate e to u, I write e to u times.
U prime.
Excellent. Well done. So then I have e to u times u prime, and I'm only differentiating with respect to x. So x squared with respect to x is 2x. Negative 2x with respect to x is negative 2. Y squared is 0. negative 4y prime, I meant y squared prime is 0, negative 4y prime is 0, 2 prime is 0. So far so good? Perfect. Now fy, same thing. E to x squared minus 2x plus y squared minus 4y plus 2 times. But now I differentiate with respect to y. This is 0, this is 0, so this is 2y and minus 4. This was our first step. Anyone remember what was the second step?
Find the system equation.
System, very good. So I have that e to x squared minus 2x plus y squared minus 4y plus 2 times 2x minus 2 is 0. And e to x squared minus 2x plus y squared minus 4y plus 2 times 2y minus 4 is 0. But if you remember, the exponential function can never be 0. So what is the only option from the first equation? That x equals,
U to the X.
this is never 0, so I can divide by it. This is never 0. E to a power is never 0.
When X equals 1.
Very good. And the second one, when y is 2. So the point in question is 1, 2. So we are trying to find whether this is a relative min, a relative max, or a saddle point. Or the test is not applicable. And we can conclude anything. Perfect. In step 3, we determine 3 more derivatives. We determine fx, fxx, fyy, and fxy. And then we will plug in 1, 2 in all of them. Okay, it's a mess. Why is it a mess? Because it's a product. And I have to use the product rule. So this is function 1, and this is function 2. First function prime times the second one, plus the first times the second one prime. Ready? So e to u prime will be e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime with respect to x is 2x minus 2 times the other function, so I'm just going to put square. And now plus, I have to erase this because they are too close. I need more room. They have to wait. I'll get to them in a minute. Sorry about that. Okay, plus e to x squared minus 2x plus y squared minus 4y plus 2 times the second function prime, which is 2. I'm going to factor out this, but I shouldn't because I only need to plug in. I really don't need anything else. So fxx at x equals 1 and y equals 2. Let's just determine the value. That's all we need. Okay, e to 1 minus 2 plus 4 minus 8 plus 2. Then 2 times 1 minus 2. Oh, look at that. So this is times 0. Excellent. Plus 2, this 2, times e to the same thing. 1 minus 2, I'm checking, that's why I'm going, minus 8 plus 2. Aha, okay, so this is 0. Nice. So 2 with negative 2, and then this is 2 times e, negative 3. Very good. Or 2 over e cubed. Perfect. Which is a positive number. Since it's a positive number, in case D is also positive, 1 comma 2 will become a relative
Greater than 0, it's
relative min. But I don't know because I haven't determined D yet. But if D is positive, and since this is positive, we will get a minimum, a relative minimum. Okay, very good. So let's continue. So now we have to find FYY. Another mess for the same reason, because it's a product, have to be careful. So e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime, which is the same 2y minus 4. But I square this because I already have to multiply by another 2y minus 4. And then plus, I copy the first one, times 2 when I differentiate the second one. Same thing when x is 1 and y is 2. So let's see. Lucky me again. 2 times 2 is 4. 4 minus 4 is 0. So this will be 0. So then it's only 2 times. And we evaluated this as e to negative 3. Because they are the same values. 1 minus 2 plus 4 minus 8 plus 2. So this is also 2 over e to the third. Okay, final step is what? I shouldn't say final. It's not the final. I need the third derivative, which is fxy. And then determine d. Okay, ready? Okay, go back to fx. So here's fx. And now I differentiate it with respect to y. This is a constant, so I do not have to apply the product rule, because when I differentiate fx with respect to y, this is just a constant. I'm going to put it in front. I'm only going to differentiate this with respect to y. So e to x squared minus 2x plus y squared minus 4y plus 2. And now times the inner function differentiated with respect to y is 2y minus 4. And now I find the value of this when x is 1 and y is 2. I'm pretty sure it's correct, but just to make sure, right? It's 1 and 2, correct? That's what we did. Yes. Okay. So let's see. When x is 1, wonderful. This is all 0. When x is 1, this is 0. Even this is 0. And here I don't care. Great job. So d equals fxx. We evaluated it already, right? It was 2 over e to the third. Fyy, 2 over e to the third, minus 0. Luckily, this is 4 divided by e to the sixth. Positive, d is positive, fxx is positive. Therefore, we conclude that 1 comma 2 must give a relative min. If we want to find it, f of 1 comma 2. Okay, 15 million pages ago, I have the function. Here it is. So it's e raised to, and it's the same thing. How much was that? I think it was e to the third, to negative 3, right? So let me double check. So e to the same, everything is the same, right? So it's 1 minus 2 plus 4 minus 8 plus 2, right? Yep. E to negative 3, so it's 1 over e to the third. So this is the minimum, relative minimum, and the function does not have anything else. Very good. So let's maximize profit now to see how this applies in functions that have more than one variable. You may create a function that has labor and has capital in it, and you may want to find the maximum or the minimum of a function with 2 variables. So what about profit number 16? on page 547. Ready? Let's read the problem. A concert promoter produces 2 kinds of souvenir shirts. Total revenue for the sale from the sale of X thousand shirts at 18 each and Y thousand at 25 each is given by. So we have a revenue, 2 different types, 2 different prices, 18X plus 25Y. The company determines that the total cost in thousands of dollars of producing X thousand of the 18 and shirts and Y thousand blah 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 is this. So we're also given the cost function. It depends on both. 4x squared minus 6xy plus 3y squared plus 20x plus 19y and minus 12. How many of each type of shirt must be produced and sold to maximize profit? So the question is max profit. How do I obtain the max profit? So first of all, I'm not interested in maximizing the revenue. I'm not interested in minimizing the cost. I have to create a function that is the target. And the target function is revenue minus cost. Very good. So let's create the function first. R of x comma y. 18x minus 25y minus 4x squared plus 6xy minus 3y squared minus 20x minus 19y and plus 12. I have to subtract each and every term coming from the cost function. If I can simplify, I will. And I can, a little bit. Just these 2 are like terms and these 2 are like terms. So I will write negative 4x squared plus 6xy minus 3y squared. So just these 3 terms for now. And this is minus 2x, done. And this is minus 44y and plus 12. This is the profit function. In step 1, we're conducting the d-test. In step 1, I have to find, so this is profit. Yes, I have to find p of x. And it's not p of x, it's the partial derivative with respect to x. It's px. When I keep y constant. So the first term is negative 8x. The second term is plus 6y. The next term is 0. The next term is negative 2. The next term is 0. And the last term is 0. Let's see if we understand this. Let's take a moment. So consider y a number. The first is negative 8x. The next one is, this is a number. I differentiate with respect to x and I get 6y. There is no variable here. It's a constant. It's gone. There is a variable here, which is x, negative 2. There is no variable here. Goodbye. There is no variable here. Goodbye. Now we have to determine py. And now I differentiate with respect to y. This is nothing. Here I differentiate with respect to y, and I get 6x. Here I differentiate with respect to y, and I get negative 6y. This does not exist. This is negative 44. This prime is 0. Okay, next step.
System.
A system, very good. And solve the system. Perfect. Number 2. Negative 8x plus 6y minus 2 equals 0. 6x minus 6y minus 44 equals 0. Let's arrange it in the correct order, moving the free terms to the other side. Negative 8x plus 6y equals 2. 6x minus 6y equals 44. Do you recommend any particular method right here, right now? The method of elimination. Negative 2x equals 46. How much is x?
23 of negative. Negative 23.
I don't like this. Did I copy the functions correctly? How can I produce negative 23? So 18x plus 25y, 4x squared minus 6xy plus 3y squared plus 20 plus 19y minus 12. So that's, I'm sorry. So 18x plus 25y, my apologies, minus 4x squared plus minus, I copied negative instead of positive, my apologies. Okay, sorry, minus 20, I can produce, I know immediately something is not right. Okay, so I'm checking now everything. Negative 4x squared plus 6y minus 3y squared. This is indeed negative 2x, but this is positive 6. Okay, so I have to change that. My apologies. So I'm going to put it here, positive 6, because it needs time to dry. So now, when I differentiate with respect to x, this is okay. This is okay. This is okay. However, this is not okay. So 6, when I differentiate with respect to y, that's correct. That's correct. Exactly. So it's plus 6. So I'm going to... No one can produce negative 23. You could say, nice try. So this is plus 6. My apologies. Okay, so now, okay, so this becomes plus 6.
Move down there.
Yes, so this is plus 6.
So it becomes positive 2.
Yeah, I mean, it's obvious that we can produce negative 23. I always say that if I teach my students to say, oops, that makes no sense, I reached my target. Of course it makes no sense, right? Okay, so then the right-hand side is negative 4. So negative 2x on the left, negative 4 on the right, which gives us x equals 2, which is in thousands.
If you have a negative production, what happens like if something breaks or you have a loss?
But that's x is the number of units. You have a loss because it's a very good question. You have a loss because you are not getting revenue. But you can say, hey, look, I produced negative 23 shirts.
Okay,
So
so
like cost of like 8 and revenue of $4. So it would be negative.
gotcha. So it was never, production would never be negative. So
Cor-
even if you
correct.
10 basis
Yes,
points
I may have
off,
a loss and not break even or make profit, but I will never be able to tell you, oh look, I bought negative through 2 cars. Right? Okay, so this is of $18 per unit. That was the 18. Okay, so we have X. Now we go back anywhere you want. So I prefer this one, which is x minus y plus 1, right? If I divide both sides by 6. So x minus y plus 1 equals 0. So if x is 2, then y is 3. Of course, 1,000. What was the other one? 25 per unit? Of 25 per unit. Good. Step 3.
For the y, how do you find that?
I plugged it in any of the equations. It doesn't matter. I have to plug in x being 2, and I solve for y. I just divided by 6. I divided
Okay.
both sides by 6. It was easier. But you don't have to. You'll get the same answer. Okay, step number 3. Find pxx, and then find pyy, and then pxy. Ready? So we know the point. The point is 2, 3. This is what we are trying to test. We found the point, but it's not enough. We have to show that this gives what?
A max or minimum.
Maximum or minimum profit. We expected it to be a maximum, but we still have to show. So pxx, here it is. Pxx, we differentiate this with respect to x, we get -8. Pyy, we differentiate this with respect to y, we get -6. Px differentiated with respect to y is 6. Is that okay? Any questions?
I'm sorry, what was that?
Differentiate this with respect to x, I get -8.
Okay.
Differentiate this with respect to y, I get -6.
Mhm.
And differentiate this with respect to y, I get 6. Everything else is gone. They're constants. They don't depend on y. Better? Is that okay?
Yeah, it's different than the last problem, but okay.
In which way? We still have to determine pxy.
Yeah,
Well,
no, that's,
the last
yeah, I know.
problem, the last problem is a bad example because they have E in it.
Okay, yeah.
Perfect. So now step 4. There is nothing I can plug in. So I can go ahead and write the d-test, which is pxx, which is -8, times pyy, which is -6, and minus pxy squared. So 48 minus 36, this is 12. D is positive. I'm happy for that. pxx is negative. What do I conclude from here? That 2, 3 is a max. Indeed. So from here, I conclude that 2, 3